Um, okay, can I start? Okay.
Go ahead.
Good morning, everyone. I'm Vicky Lam from University of Hong Kong. Today, my talk is about school-based low-cost sensor network is used for urban heat island studies. Now, today I'm gonna break down into few parts: motivation, talk about a little bit about research method at the end, give you some overall discussion. So the motivation, as we know, United Nations in 2015 start having some global sustainability goal, and urban is a one important part of it. And in Hong Kong, we do have getting more attention about urban heat. And recently, we have established a occupational safety guideline for outdoor workers and require them. The Hong Kong Observatory will release daily forecast output based on different warning. When it's get wet, some worker had the owner of the company has to let them to have a rest every 15 minutes per hour. So there's something in Hong Kong. We are because we are fully urbanized. At the same time, um, uh, because of global climate change, recent years we have seen temperature close to 40 degrees Celsius. So when 20 years ago, I was very happy to have 30 degrees Celsius because I can go swimming. But now we can often see 40 degrees Celsius. So in the forecast, normally we do a regional climate model like WRF, and but at the same time, this type of forecast output may not able to give us the real local data. It's different when we forecast, we can get probably up to 1 kilometer resolution, but when we're looking at local environment, then it's talking a point. So we need to do something to how to connect these things together. And in our when we're looking at microclimate research, we have not sufficient urban scale observation. When we say urban, I think I have to define a little bit different from the most of audience here. When we're talking about urban in Hong Kong, we're talking about building next to buildings, and only have a street in between, and there's nearly no trees. Okay, probably it's different from the urban area we talk about in Europe, but we're talking about almost whole part, a larger part of Hong Kong are in that kind of condition. Now, because of in Hong Kong, I usually describe as a donut shaped urban development, and we have a mountain in the center, and then we have buildings built along the mountain, and as a result, the spatial and heterogeneity of urban the temperature data are really huge. So that's why we need a much better spatial scale data in order to understand the local urban island. And for Hong Kong government, they do Hong Kong Observatory has about 20-30 stations. But the problem is they usually follow the WMO standard. That means they're not really urban stations. Okay, when we say urban station, once again, it's slightly different definition. Now, of course, we used to just looking at how we compare with WOW, but now we all looking at us as a global citizen and how to save the environment. And so we come up with a multidisciplinary approach. We try to create an urban climate network, observation network. We injected the idea of citizen science, also school network. At the end, we can teach students at the same time, build up our network, and also use the data to do our research. Now, when we're looking at urban climate data, we have different level. Now, from the top part, which looking at WMO standard station, which is you have a screen box and then you put your sensor in the temperature meter in it, and then we have the community level, which we might use commercial types of, like Davis Pro. We have speaker earlier using it. We also have people using Hobo. Those are commercial available, but may not install based on WMO standard, which is 1.5 meters with a box, and then have to have greenery below. So completely different environment. Now we jump down all the way to the citizen science weather station, which we start doing using IoT technology, and then also crowdsourcing. Now, when we're talking about citizen science, we looking at everyone can be a scientist, but of course it's not. You just have that. You have the inquiry. You want to know about it. You concern about it. Then you do it. And we want to try to combine modeling, also STEM education, to create a win-win situation. And decentralize the monitoring network, just operate by the government, but give it back to the citizen. Now, this is from the weather station from government, and our team is currently operating a called Cowin Weather Station Network, which using Davis Vintage Pro 2 and which install on top of the wood top of all school buildings. And we have about 120 members, and of course, it's difficult to maintain when you're doing a large network. And but those Davis Pro 2 usually last for at least 6 years without too much problem, which is quite reliable. But only for school, then we can only have 100 of it. But if we want to expand it, Davis Pro 2 costs about thousand US dollar, and it's hard to replicate, for many places. So we start looking at the option to create a Covin tool which using Arduino based weather sensors. And we use a solar panel. Also, we use a LoRa for communication. Now, when we're looking at STEM education, we try to integrate in a geography. And if you look at geography, we have a field work, and students using instruments. And by adding developing instruments, students can learn the science and engineering part. At the same time, we can also inject big data, geo information like GIS, GPS, those things, also other environmental applications, so that students will gain their benefit. At the same time, teacher will like it because you do their job. At the same time, we all getting the data we need. Now, in our team, we do regional climate modeling, urban climate modeling, and we do citizen science. And we start doing with 27 kilometer resolution and down to 9 kilometer, down to 1 kilometer, 3 kilometer, and down to 1 kilometer. At the end, we have to rely on local measurement, and and then we can integrate model with local measurement. Eventually, get land use regression modeling to put it so that we can get to create the spatial map. Now I show you three different examples. The first example, which is we do a vertical measurement in one of the school. We install Arduino-based sensor in different floors, and we develop different scales so that school can adopt it, and then to warn their student when they're doing a sports event or other stuff, they have to make their own guideline from the school. And the the same picture but with different orientation. We do have all these land use information, and we putting in not just the vertical but also in the playgrounds. And one thing we find that in this type of sensor measurement, when you very next to the building, you need at least half meter away from the wall. Otherwise, you will start getting influence from the wall. At the same time, you have to careful about the solar radiation because that heat up very quick. And if you do in minute data, it create a huge difference when you compare with hourly data. So that's kind of experience we earn. And we also fly UAV, go to on the top looking at whether we can see any hot spot. In fact, when we look in our measurement data, when there's a sunlight, the temperature difference can range about 4 degrees difference within within the school. So which is a large part of it. And when school try to implement different policy, they need to know the location dependency. We do some QAQC compare with the Hobo data, and this is the one-to-one line showing here. It turned out pretty good with the Hobo data. And then we're looking at different floors, and what we find that lower floor seems to have higher temperature, uh, only when it's very high during the with the sunlight, and upper part seems to be less less impact, and humidity seems to not as good as temperature, and but doing quite well. But the similar humidity can find when in with a different floor. Okay, the second project we did, we work with students. We have different, we went to different places in certain area, which have a river, and you will see there's a large difference in temperature. That can create a nice project for students, and and after they get back the data, we we create have a discussion section. We also give them some reading so that they can understand urban climate. But at the same time, we can actually receive their data and use it for research. So creating the win-win situation. Okay, so and we use different data and we try to come up with a extreme heat forecast, and then we try to create a comfortability index. And last, when we're looking at STEM initiative globally, and also the citizen science is the opportunities, and it can expand our observation network, and we can actually create location specific weather alert, and we can create tailor-made model forecast for decision maker. So it's when we're looking at this thing, we can do it together instead of looking at just scientific study. It is a win-win situation there. Okay, this is my knowledge. Thank you.
Thank you very much. Questions? Yes.
Thank you for the nice presentation. I just had a question concerning the lower signal that you use for certain of your sensors. How far did it, like how is the lower signal behaving in Hong Kong in such a dense urban environment? Do you have a general coverage that is provided by the city, or do you have actually to have certain hubs that create this lower signal that then communicates to your sensor? And if so, what is the distance to which they can reach?
Okay, we have tested at least 1 kilometer in range, but for the school project, we have a gateway installed in school, so that use Wi-Fi, and then we have direct line point of sight, and we create bridging, so that one sensor send the data to same device and then go through. So all our devices have a direct line of sight at the end to the gateway. So that's why we can get a pretty good signal from there.
Yeah, okay.
And also we create our sort of lower rank our own version so that we don't get interference from other people's data. Yes.
Yeah, cool. Thank
Yes.
Yes.
It's a very interesting presentation. So I like to know the comfortability index that you estimate is very utilized, can be used only for your study area, or it can be used
Well, we
elsewhere?
think
Or how do you
okay.
estimate that?
Okay, we're looking at the index that used by the Hong Kong government, also the index used in US, which doesn't rely on wet bulb temperature. Those are based on dry bulb, which is the air temperature. And when we create it, we scale a little bit so that it fits the urban environment in Hong Kong. So in some way, I think it's a little bit local dependent, but can be used in a large big city. Yeah. Thank you.
Okay, thank you very
Thank
much.
you.
We move